Okay, today we're going to learn about substitution and elimination to solve systems of linear equations. Hopefully you already have a good base of how to do this from Algebra 2, and this should just be mostly a refresher for you today. All right. So the very first thing I want to do is I actually just want to apply this to a real-world example, and we're going to develop our own system. So a movie theater sells tickets for $9 each, with seniors receiving a discount of $2. One evening, the teacher took in $47.60 in revenue. All right, so that's the amount that they took in. All right, one ticket is sold at $9, and the other type of ticket is sold at $7. So when we develop the equation for this, we should get that 9x plus 7y is equal to the amount of revenue that we took in, which is $47.60. And then in the next part of the question, it says, suppose that we also know that 600 tickets were sold. So now we're not talking about price, we're just talking about the amount of tickets sold. All right, well, one type of ticket is X, and the other type of ticket is Y. So when we sum those together, we get the total amount of tickets sold, which is told to us 600. All right, and here we've developed a system of equations. Okay, we have two variables and two equations. All right, let's talk about the different methods of solving a system of equations. Okay, one of the things that we can do is we can use substitution. All right, this first one that I did, I have two equations, all right, and two variables, and I went ahead and solved the second equation for y. All right, so because I'm going to use substitution here. Well, if we know that this equals y, I can plug that into my equation so that we get 3x plus 2 times, all right, and y is 2x minus 5, and this is all equal to 18. Now we just solve this like a normal Algebra 1 equation. We'll distribute, combine like terms, and solve for x. So when I do that, I get 3x plus 4x minus 10 equal to 18. Now let's combine like terms. I get 7x. All right, and I'll add 10 to the other side so that we get 28. So 7x equals 28, and x equals 4. Now we solve for x. Now we need to find our second variable, which is y. So I'll plug in that into my y equation. So I'm using this blue underlined equation, and I'll plug my x value in to get what y equals. So y equals 2 times 4 minus 5. We do 8 minus 5, and we get y equals 3. Right? There's two ways you can kind of present your solution to me. You can either box your two different variables that you solve for, okay? Or we can go ahead, this is an XY solution, we can go ahead and list it as an XY ordered pair, all right? So if we list it as an ordered pair, it would just be 4, comma, 3. There's another way you can write your solution. Now let's talk about elimination. So elimination is when I'm trying to eliminate a variable from the equation by adding the two equations together, all right? And one of the other things I can do is I can add the two equations together, or I can multiply one of the equations by a number and then add it to the second equation. Right? Here, we don't need to do this, okay? If you see, if we were to add both of these up here, right, we would get that the y's would cancel, all right? So this one's nice for us. It's already ready to go. All right, but in other ones, we may have to multiply one of the equations by a number to get something that will cancel out to 0. Okay, so let's go ahead and combine these by adding them. So when I do that, I end up with 8x, 2y plus negative 2y just ends up being 0. All right, and then 1 plus 31 equals 32. All right, now we'll solve for x. So we get x is equal to 4. All right. And then the other thing we'll do is we'll go ahead and plug this into one of our equations. We can do it into either one of them, all right? So we'll do 3 times 4 plus 2y is equal to 1. Right? And then I'll solve this equation. So I'll subtract 12 with both sides. I get 2y is equal to negative 11, all right? and then I'll divide by 2, so I get y equals negative 11 halves. Right? So this is the method of elimination. Hopefully at some point you've learned this in your previous math courses. If not, it's pretty straightforward. All right. Let's go on to the next slide. All right, this is a U-track, so why don't you guys go ahead and actually try to get your equations for these and figure out what they would be. So I give you enough information to develop 2 equations. So if you want, if you guys can go ahead and pause the video for about 5 minutes, solve this, and then we'll continue. All right, hopefully by now you've had enough time to complete this problem. I'll go ahead and kind of sum it up for you. Basically, we're told that we can grow 1,000 acres, so x plus y is going to equal 1,000, all right, where x would be the amount of corn and y would be the amount of soybean, okay? And then we got one other equation that tells us 75 times x plus 50 times y, right? This is your cost equation. It's equal to 65,000. Right. Now we have a system of equations, and we can go ahead and solve this either using substitution or elimination, okay? Why don't we do elimination for this one? All right. So what I'm going to do is I'm going to go ahead and eliminate y. I could eliminate x, all right? It really makes no difference, but I'm just picking y this time, okay? So I'll multiply this top equation by negative 50. Notice I put brackets around the whole thing because I'm going to be multiplying the entire equation by negative 50. Then I'm going to go ahead and add it to our second equation. So if I do negative 50x plus 75x, I get 25x, all right? My y's are canceling out by design, all right? And then I have negative 50 times 1,000, which is negative 50,000. All right, I'm going to add that to 65,000. So I'll do negative 50,000 plus 65,000, and I'm left with 15,000. The last step will be to solve for x, and then we'll go ahead and plug that in and get what y is. All right. So if we do 15,000 divided by 25, we find out that x equals 600. And then I'll go ahead and plug that into either equation. I'm going to go ahead and plug it into the top equation. So 600 plus y equals 1,000. I picked the top equation because it's a little bit easier to plug in and solve there. All right, and then I'll subtract 600 to each side, and I get that y is equal to 400. All right, so they grew 600 acres of corn and 400 acres of soybean. All right, so here's some graphs to explain the different types of solutions that we can have for linear systems. All right, we can have that it is one solution. We call this a consistent system, and it's also known as an independent system. This occurs when our lines, because again, we're doing systems of 2 equations, so these are 2 variables, which are our lines, okay? When they intersect at one point, we have one solution, and again, we call it consistent or independent. Now, we can also have a dependent system. Okay? A dependent system occurs when I have coincident lines, meaning that the lines are exactly the same. You can kind of tell in the picture here, hopefully, that they have a blue and pink line that overlap in their entirety. So the lines are overlapping the entire time. There's infinitely many solutions because they're the same line. All right. I skipped one. Let me go back one. All right. We can also have an inconsistent system. An inconsistent system occurs when there is no solution, all right? And that will happen when we have parallel lines. All right, the next thing I want to show you is I'm going to show you how to solve these with the graphing utility, all right, which isn't too difficult. All we need to do is solve these equations for y, and then we're going to plug that into our y equals. you probably have been shown this before, but this will be a good refresher. And for those of you who haven't seen it, it'll be a great tool for you to use in the future. All right, so we'll solve both of these equations for y. I'll start with the top one. I get negative y is equal to 13 minus 2x, and then I divide by negative 1, so I get y equals 2x minus 13. All right, just basically flip the sign of both of my things on the right. The second one I'll solve for, I end up with negative 9y is equal to 7 plus 4x. And then I'll divide the entire thing by negative 9 so that I get y equals negative 7/9 plus 4 over 9x. Now that I have both of them in y equals format, I can go ahead and pull up my calculator here. So hopefully you guys have your TI-83s or 84s out. And when I pull it up, I'll go to my y equals. All right. And notice that I've already put both of those equations in there. So I have 2x minus 13 and then my second one that we solved for. All right. You'll click graph. And then those are the two lines graphed. Clearly we have a consistent system here with one solution. And the way I'll find that one solution is I'll hit second trace. All right. And when I hit second trace, I'll go down to intersect and hit enter. And then I'll guess my first curve and then my second curve. All right. And then I'll guess where I think the intersection is, right around there. All right. And then it gives me my solution. It tells me that x equals 5 and y equals negative 3. All right, so we can write that down as our solution. Okay, so this is a quick way and a great way to check your work, make sure that you're solving these systems correctly, all right, by finding the intersection. The only issue with using the calculator is if I get a problem that has a really big x value and a really big y value, say that like the farming problem that we had just done. Well, we got x equals 600 and y equals 400 as our solution for that one. And see, this graph isn't big enough for that. So what you'll have to do is, if you're using a calculator to do a problem that has that big of answers, is you have to adjust your window until you can see this intersection happening. All right, which can be pretty difficult to figure out if you don't know what ranges you should be in. All right, so it's good that we can do it by hand and then maybe check it with our calculator. All right, so now we're going to discuss inconsistent and dependent systems, okay? Basically what we have to do to show that something is inconsistent, if you remember from the graph previously, we had inconsistent system when the lines were parallel. Well, for lines to be parallel, that means that they have the same slope. All right, so let's go ahead and just show in this first example that it has the same slope, and then we'll show that the lines are parallel, meaning that we have an inconsistent solution or inconsistent system. Okay? Well, the way I'll do that is I'll go ahead and solve for y. All right? So when I do that, I get 2y is equal to 8 minus 3x. And then I will divide by 2 on both sides, and I get that y equals 4 minus 3 half x. All right? So I divided by 2 throughout the whole thing. Now if I solve my second equation, all right, again, we'll subtract 3x over, so I get that 2y is equal to 12 minus 3x. And then I'll divide by 2 again, and now I get that y is equal to 6 minus 3 half x. Well, now I have it in y equals mx plus b format, where m is my slope. So if you look at these two slopes, I have negative 3 halves right here, and I have negative 3 halves right here. So since they have parallel lines, we have an inconsistent system, okay? So whenever this occurs, whenever you have two lines that have the same slope, that'll be an example where you have no solution, okay? All right. the second one, we have dependent solutions when the lines are the same. Well, you'll notice that these lines actually are the same. Really, it's just the first line, if we multiply it by 2, we end up having the same line. So I have 6x minus 8y is equal to 20, all right? When I multiply this thing by 2. Well, that's the same as the other line. If I were to try and do elimination at this point, if I were to subtract these two lines, all right, I would end up with 0 equals 0. Whenever we find this result, we know that it is a dependent system. Okay? So if you end up having something where you get 0 equals 0 when you try to solve this thing, you have a dependent system. All right? All right, so here's a few for you to try. At this point, if you guys could pause the video, the sub could pause the video, and take about 20 minutes, maybe 15 to 20 minutes to solve these problems, all right? So you'll do 1, 2, and 3. There may be an inconsistent or dependent one in there. You'll just have to find out by trying to solve them, all right? And then on the next page, there's also a word problem. We're going back to that movie theater example, but this time we're actually going to solve it. So you already have the equations for this one if you look back at the first example that I did, and then go ahead and try and solve these. All right, so there's 4 problems. Take about 15 to 20 minutes and see if you can get the answers. All right, now you should have found the answers. So I'll give them to you. You can kind of check your work. If you don't have them, just hold on to your questions and I'll explain when I get back. All right, you should have gotten inconsistent for the second one. All right. And for the third one, x equals -3 and y equals 31 halves. Okay, so 31 over 2. All right, so there's your solutions. Hopefully you got the right answers on those 3. And then for the word problem, you should get that x is equal to 280 and y is equal to 320. All right, there's your solution for the word problem. All right, the last thing we're going to do is I'm going to show you how to solve a system with 3 equations and 3 variables. Now, I don't know that you've seen this yet, so I'll take this one a little bit slower. All right, but essentially what we're going to try and do is we're going to use elimination so that we can eliminate one of the variables and have 2 equations with 2 variables. Because at that point, we know how to solve that, right? We just did a bunch of examples and a bunch of you-try problems of 2 variables, 2 equations. So when I start with 3 variables and 3 equations, I'm going to try and eliminate one of the variables. All right? Well, the way I'm going to do that is for the first one, right, I'm going to multiply the top equation by -2, right, and I'm going to add that to the second equation. So I'm going to try and eliminate y here. And I just picked y because I just wanted to take out one of the variables, and that was the first thing I saw that I could do. All right? So I'll multiply by -2. When we do that, we get -4x plus -3x, which is -7x, right? And then the y's cancel out because it's -2y plus 2y, which is 0. All right, and then I'll do -2z plus -2z, which is -4z, and we'll get that is equal to -18. All right. Now, the next one that I'm going to do to get another equation is I'm just going to add the second and third one. And there's so many ways that you could solve this system. This isn't the only way, all right? But again, the idea is, all right, so I decided to take the track of eliminating y, so I need to combine 2 other equations to eliminate y again. So that way I have it down to x and z. All right, well, I'll basically just add the second and third equation to each other. So I'll add these 2 right here, all right? So negative 3x plus x gives me a negative 2x. 2y plus negative 2y, well, again, that cancels, that goes away. And then negative 2z plus 3z would equal a positive z. All right? And then I'm going to add negative 10 plus 7, so I get that's equal to negative 3. Well, now I have it down to a two-variable system, and when I have it in a two-variable system, we can either use substitution or elimination. All right? I'm just going to keep with the theme here. I'm going to do elimination. The easiest thing I see to do is just to multiply the second equation by 4 and then add it to our first equation. So when I do that, all right, and this is going to be to eliminate z. We do 4 times negative 2x, that's negative 8x. So I'll get negative 15x, all right? And then 4z plus negative 4z, that goes away. 4 times negative 3 is negative 12. Negative 12 plus negative 18 gives us a negative 30. All right. And now I'll solve for x. So x is equal to 2. Right? If I divide both sides by negative 15, I'll get that x equals 2. All right. Now that I know that x equals 2, I can go ahead and plug it into either one, my top equation or my either this one or this one, all right, and solve for z. So I'll plug it into the bottom one. It's negative 2 times 2 plus z equals negative 3. All right. So I get that negative 4 plus z is equal to negative 3. All right. Well, if I add 4 to both sides, I'll get that z is equal to 1, and now I've solved for z. All right. Well, the final step here is to now go back to our original 3 equations, all right, and plug in our x value, plug in our z value, and then we'll figure out what y is. Okay. So I'll do that. I'll go ahead and plug in to, let's pick the top equation. So it's going to be 2 times 2 plus y plus 1 equals 4. All right. So I end up with 5 plus y equals 4. And then when I solve for y, I'll get that y equals negative 1. So a little bit longer of a process, but again, we're just using elimination. We're going to eliminate one of the variables, get it down to 2 variables, 2 equations, and then solve it like we've done in the past. All right? If you wanted to write this like before when we did like an ordered pair, well, now we have an ordered triplet where we would do x comma y comma z, and the particular solution for this one would be 2 comma negative 1 comma 1, all right, which are the values that we found for x, y, and z. So on the next page, there's a U try, okay? So go ahead and do that as part of your assignment, all right? And then I gave you the following numbers. It's all odd. Go ahead and get this knocked out as classwork. Whatever you don't finish can be homework, but you should have plenty of time to get this assignment done and get everything squared away. All right, there are a couple of challenge problems in there. Try and work through them and do your best. And we'll go over any questions that you may have on this lesson next class.